Oracle, the database, we'll understand basically what is meant by a database. Just give me a second. Okay. So what is a database? Database is nothing but a platform, a location, or an area, you can say, where you're going to save your data. For it, you're going to provide a certain security to it. So whatever the data you're saving in one location, you're saving it for the purpose of for referring it whenever required. So for further reference, you're going to store the data, okay, in a location. So which is that location in a real time in a companies? The companies have their own servers, right? So on the server, the location has to be prepared where data going to be located and stored. So on the server, you're going to install a database. So that's the reason we say, what is a database? It's a platform where you can place your data for further reference. So what kind of data it is? It's a collective information. The information can be of any entity. You mean to say the information can be of a school, education, or an employee information, anything. Okay. So it's a collective. It's a collection of interrelated data. Why we say this as an interrelated data? Because the data, the information which we are collecting and storing, it's not only an independent, it's a related data along with some relationships. Right? How an Excel sheet look like a rows and columns, right? In the form of a cells. The same manner, the data is also going to reside on the database. So coming to the different versions, because in market you have different databases. You have Oracle is one of the database, MySQL, Sybase, NoSQL. There are multiple databases. But when you compare with respect to the other database, Oracle is the one database which provides 100% security to the data which you are storing. So that's the reason most of the companies are preferring this database, Oracle database. So what are the versions? Next point is, what are the versions of the database? Right now, whatever the version we are currently is in the 12C version, Oracle 12C. So before 12C, it started with the version 2 point, then 3, 4, 5. So on, we came up to Oracle 8, 9 also, 8i, 9i, 10G also we are aware of. Nowadays, some companies are also using 10G version, 11G as well as the 12C. Now the current running versions are 10G, 11G and 12C. Okay, so each of these versions have their different releases, release 1 and 2. Now everyone, once if you want to practice on this Oracle SQL and the PL SQL queries, first of all you need to install the database on your laptops. Okay, so if you have already installed it, no worries. If you have not installed, we'll understand how to install that software. Download it first. Initially you have to download it and then install it. The installation steps are straightforward. Okay, it's just only to follow the wizard. Now you may ask us, like a question may arise that whether we should install 10G, 11G or 12C. Even though we are learning the course of 12C, as for your comfortness, you can install any of the versions, either 10G, 11G or 12C. See, these different versions make a great difference with respect to a database administrator. So the people who are learning DBA, they have a lot of changes and the features in the version wise. For a developers, that doesn't affect so much. You can also practice on 11G or 10G or 12C. So you can install any of these versions. Okay. So from where, now let's understand just from where will I get this software. So what you can do is you can just browse for, you can go to the oracle.com. The official website. Just go to menu. Here you have database and trials. There you can just browse for the downloads, databases, and here you have Oracle database. Now you'll get, right now Oracle site has the only two versions of softwares, that is 12C version and release 1 and release 2 and 11G version, release 2. It don't has the 10G or the release 1 of the 11G. So if you're interested, you can install this software of release 2 11G version or release 1 or release 2 of 12C version. Okay, now you need to check according to your operating system. If you're working on Windows operating system, you need to just, from this list, just go for the Windows operating system, whether it is a 32-bit or 64-bit, just download these two files. And the size of these two files after downloading, it should be 2 GB. Okay, make sure that once you're trying to download this, the Oracle will ask you to just register with the Oracle. It's just a normal registration. Enter your email address and password. Then you will be able to just download it. I'll just show you how to. It's saying sorry, accept before downloading. So accept the license and then just file 1 and trying to download. So when it is asking me to sign up. I will try. Password. I think password, I just forgot it. So you can just do one thing. You can just sign up. You can register, create an account, sign up. Once the valid credentials are provided, it will automatically install, download, start downloading. So in this way, you need to just download both these files, file 1 and file 2. After that, you need to copy the data, the content from file 2 into file 1. Okay, and then just click on the setup application file. It will follow, it will open the wizard, and just you need to just say click next, next, next. That's it. And later, before ending up, there you'll get one option of passwords management. Password management, where you can just unlock few users. Unlocking few users means those users would be active for connecting to the database. So if Scott is available, you can unlock this Scott. You can give the Scott user some username and password. Usually we give as Scott and the password as Tiger. Okay, password as Tiger. And there can be some HR user if available. You can unlock him also. You can set username as HR and also the password as HR. And along with that, you have system is one user. For him, you can assign a password as manager. And there's also SSDBA user. You can also give him assign a password of manager. So you can just make a note of these are some standard passwords we provide to these users. These all are users. Scott is one user, HR is one user, system is one user, and SysDBA. The system and SysDBA are kind of an admin. They are admin. And Scott and HR are normal users. They are users. Okay. So using these, once you unlock these few users, apart from that, you will find many more users. You don't need to unlock them. You can adjust. Once you unlock these users would be connecting to your installed database. Now how to connect? See, now you can do one thing because it would take some time to download this software, and already I have database already installed on my machine. We can do one thing. You can, if you are able to do installation on your own, you can do it. If not, just any one of you just download these required files based on your operating system and keep it ready so that in the next session I can help you in how to download the software, okay, the database and even the tool. Now how once the database is downloaded, how will you connect to the database? Because you can't directly get into the database and work on it. It's a storage location, right? Now, how will you interact with the database? For interacting with the database in real time, we use some tools known as, the tools are Toad. Toad is one tool, or SQL Developer, or SQL Plus. SQL Plus is something where you need to write your query on your own. It's a little bit working. You need to work on it more. But Toad and SQL Developer are something kind of GUI. It's a GUI based, where you can just copy, paste, rerun it, edit it. It's easier to work on that. So it is based on the company. Some companies prefer going with the SQL developers, and some use this Toad tool. Now, from where will you get these tools? You can look from in the menu of the Oracle site. Here the developers. Developer tools. Here you can see a Oracle SQL Developer. You need to even download this file. Just click on download. Developer 7.4 version it is. Accept the license. Now this is the place where you can download it. Now when you're downloading this SQL Developer, make sure that you have even JDK files as well. That is Java JDK files. Don't take if you are able to manage or download the JDK separately, you can do so. If not, try to download the file of SQL Developer along with JDK. Sorry. You need to just click on the download. Once downloaded, you'll get a software installed in some location. Sorry. Yeah, this is the SQL Developer. Okay, you'll get a SQL Developer zip file. Once you just extract it, the extracted file is here. This is a SQL Developer after extraction. Once you open it, here is an application file, sqldeveloper.exe. You need to just run this, that's it. It will automatically open a GUI environment. So we'll go to that point, how it will be. So this is an SQL Developer shortcut after launching the tool. Once I double click on that, you'll get an environment where you can and you need to connect to a database and start writing queries on that tool. Make sure that when you're trying to download this file, make sure that you have a JDK along with it. Otherwise, explicitly you have to configure the JDK. Apart from this, let it open. Along with that, I have this SQL Plus environment. You can also use this tool if you want to just work on this explicitly by writing commands. Here you need to pass the credentials so that you can try to connect to the database. So I'm just saying I want to connect with a Scott user. Scott is the username. The password I give as a tiger, and the connectivity string, this connectivity string here I have is a ORCL. This you need to provide during installation of a software. So once the credentials are valid, it connects with the database. Okay, see here the database which it's on my machine is a 11G version. Okay, and you get this connected to the database, and this is the version, edition version, and this is the prompt, we say SQL prompt, where we can write queries here. So I want to see to which user I'm connected. For that we have a command known as a show user. Enter, saying the username is a Scott. So right now we are connected to the Scott schema. So whatever the queries we would be executing here, that would be referred or communicated with the database through Scott user. Okay, so this is a kind of a SQL plus environment. You can work on this tool, or this is the one, the SQL Developer. Now here on the left side, you can see the multiple connections. These are the different users, Anil, Orafai, Scott, Uma. So these are the different users, schemas. So how will, after connecting to the database, you need to just create a connection. How to create a connection? Just click on this green plus icon. This is the connection details. You can give any connection name, any name. I'm saying U1. Now, before that, you should have a user to your database. First of all, a user should be there. Then only you can create a connection. Now, suppose what I would be doing is, already I've connected to Scott. Scott is a normal user. I'll try to connect to an admin. How do I connect to an admin? CONN, connect, system, manager. At the ORCL. Username / password and the connectivity string with an @ symbol. Connect to this user, we are saying. Enter. If the credentials are proper, it will connect to this schema, system schema. So connected. Let's see, show user. We are connected to the system. Now what we will do is, in the system, we are going to create a new user for our session. So the syntax of creating a new user is create user, the username Intel, password identified by. Identified password is also Intel. So this is the syntax or the query to create a new user in our database. Create user, username identified by password. So enter. A user would be created . User is created. Now this user don't have a privilege of creating a session. Unless you create a session in the database, you can't work on that. So how to give a permission for this user to create a session in the database? For that, we need to grant some privileges. How to grant it? Grant is something you're giving some privileges. What privileges? Resource and connect to the user, that is Intel. I'm giving the privileges of using the resources and creating a session with the help of commit. These are the two roles given to this user. Granted. Now what I can do, if you want to test here whether I'm able to connect to this user, you can also test how. Just say connect. What is the username? Intel. Password is also Intel with the connectivity string ORCL. Connected. Show user. So it's connected to the Intel user. Now, what are the objects in this? This is a new schema in the database, new user, right? So what are the objects? I mean to say, are there any tables in this user, in this schema? To see that, I can execute a query, select everything from the tab. Means get me all the tables list from this user. There are no rows in this table. They're saying. Okay, so there is nothing, the schema is blank now. Now for our purpose, what I will do is I'll generate one script and create some tables in this schema. Okay, so for that I have a script here for just a demo tables where I can create some dummy tables. See, this script we are going to anyway learn how to write this script. I'm going to execute here in this. Means it is, you're just writing a script. One script got done. I'll write the same query. Select data from the tab. Now I have two tables, DEPT and EMP. These are the two table types, tab types. They are tables. So in our schema, Intel, we have two tables. So I already in the database, we have one user. Now this user, I'm going to access with this tool, SQL Developer. There's no Intel here user. I want to create a new connection. I'm clicking here. The connection name is Intel. What is the username? Intel, yeah. So what is the username in the database? Intel. And password is also Intel. I don't want to, every time whenever I open this user, I don't want to give the password. So I'm saying save password. It's a local host, no port number. Here I have to give ORCL, your connectivity string. I want to test this user. Test it. Here you should get a status as success. Then only I can connect. Now you can see a new user is available here, Intel. If I want to work on this user, I need to just, once you open this tool, you need to just double click on this Intel user. That schema would be loaded. Okay, now here I can write any queries now. Select data from tab. Now for execution, what you should do, select this command. There's a symbol over here, run the statement. After execution, below you can see the result once executed. This is the query result. You have two tables in your schema now. DEPT is the table name, EMP is the table name. Okay, so what I would do is I would just close this session, close this SQL Plus. So now as we are already connected to this SQL Developer. So henceforth throughout our session, we will be connecting to the Intel and working in this schema with the database. Okay, so whatever queries we write here, that would be communicated with your installed database. So what I would suggest you, first you install the database, then whatever using that tool application, you run this application so that it would open this SQL Developer. Then you create a new user and connect that new user as a connection to with your SQL Developer. Okay, so this is the installation part. Hope that's clear to everyone. Any queries from anyone? Okay, fine. So we would go ahead next. So we understood the different versions of Oracle database, and the current version which we're going to use is the 12c. or 11G. Either 11G means release 2 and 12C means either release 1 or release 2. Clear? Now we have already installed it. We have the tool with us and already created a new user and connected to the user as well. Now we will understand why nowadays this Oracle is known as an RDBMS technology, Relational Database Management System. So which were the different models before this RDBMS came into existence? So we'll have a just look over it. The first database model was with a FMS, File Management System. So what is file management? Whatever the records and the data you have, you're going to store it in the form of a file. Suppose I have 1 lakh of records. Okay, all this 1 lakh of records, I'm going to save it in the form of a file. Okay, so first data would be stored as a first row, then second row, then third row, in this way, sequentially. So what is the problem, disadvantage with this file management is, out of 1 lakh record, I want the 50,000th record. So how will I retrieve it? How will I get it? In that case, I can't directly jump to 50,000 and get it. I can't write a select query in that way. I need to go sequentially. It will check the first record. Is this 50 record? No. Second record, third record, so on, up till 50,000. So that means it is a time-consuming process to retrieve your required record information. So that is one of the limitation in the file management. And apart from that, there are many more limitations like it don't have any data type separation, duplications are stored. So these were some of the disadvantages. After that, they came up with the hierarchical database system, HDS. Hierarchy means layers, different levels. You mean to say level 1, level 2, hierarchy based on their privileges. Different permissions are given. So in this case, you could retrieve, you could go to your required record faster, but thing was there was no proper communication between different levels, different hierarchies. So there was a lack of communication between the different levels in the system. So that's the reason they went with a network database system. Networking means all the layers, all the nodes, all the tables, you can say they are interrelated. Okay, they all are connected to each other. As they are connected to each other, but how the connection was? Through physical links, cables or something, right? So the communication was happening very well, but the problem was because of the physical links, there was a fear factor or there were chances of disconnecting the physical links. So due to disconnection, there was a communication breakage. Okay, there was no communication, but it was, you could able to identify the error or where the damage to the communication or the links were, but it used to take some time. Means the disadvantage in this network database system was the communication was good, but the communication were through physical links, and physical links there are chances to disconnect. So that physical links are replaced with logical links in the relational database system. Okay, so in the relational database system, the multiple tables, the multiple objects means what? In database, we term each and everything as an object. As we say, everyone are human beings. Okay, so my name is Lakshmi, your name is something like that. So all generally we say everything is an object. Table is an object, view is an object, synonyms, sequences, all are objects. Procedures, functions. But each object has a specific name. The table, view, synonym, something. So how are those tables or how are those objects connected? With the help of logical link. So what is meant by logical link? That you can understand in the constraint topic. Constraint part we will be discussing that, foreign key, primary key relationship. So the different objects are related to each other with the help of setting some logical links. So that's the reason nowadays we call our database, we say it as an RDBMS technology based, relational database management system based. Clear? Now, what is RDBMS? That's what you're storing the data in a tabular form, right? As it is a table, obviously you'll be storing your data in the table form only, right? What is a table? It is in the form of rows and columns. Before RDBMS technology came, there was a DBMS. What is DBMS? You're storing the data in the form of file. FMS, we said just now we discussed, right? So that's nothing but you're storing your data in the form of a file. Next, we'll understand what are the features of this RDBMS technology. So this RDBMS technology was structured or designed by E.F. Codd in 1970. So as we said just now, discussed, everything is known as an object here. All the components in this model are known as an object. It is based on a logical representation. It supports the data integrity and consistency. Data integration means what? You're collecting the data. See, the data can come from multiple input sources. You may get the transactions done from Amazon, Snapdeal, right? Flipkart. They are nothing but information, data, which has to be stored in a database and later analyzed. How is the business going on, monthly wise, quarterly, or yearly, half yearly, in that way. So you're integrating the data, you're taking the data from multiple input sources and maintaining it in one consistent form. It supports data integration and consistency. Apart from that, no physical links. It supports null values. What is null value? Null value in the sense nothing. So if you look into here, I have a table known as a EMP. Let's write a query on this EMP table. Select data from a table name. So what is that select query is? Selecting something from a database. I'm retrieving data from a database. Asterisk means get everything, all the data, whatever is there in that table. From where? From this table. The table name is EMP. Already the table is EMP. Right? But here you can see the table name is in caps, but I'm writing in a small case. Oracle is not case sensitive. Okay? So you write your query in a small case or uppercase. Oracle is not case sensitive. So what does this query means? Select all the information from this table. Select it, execute the query. We would get the columns from the EMP table. EMP table has these all columns: employee number, name, job, MGR, hire date, sal, commission, department number. Under these columns, you have multiple rows. Many rows are there, records. But if you see under the commission column, there are some null values are there. Null, something, right? And some are filled with some numbers and something is with 0. So this is known as a null. So you can enter a null to a column. Null means neither 0, nothing. It's blank. That is null. So that is the feature of this RDBMS technology. It supports null values and constraint. Constraint means placing some restrictions to the columns of a table. What kind of restriction? Like if you look into this table, there are employee numbers. When you think logically, we ideally say the employee number should be unique, no duplication, right? So how will you set that to a column of a table with the help of a constraint? So in the constraint, you have one constraint name known as a primary key. If I set a primary key to this column, automatically the nulls would be restricted and nulls also would be restricted. Null means primary key. See, there should not be no employee with ID, without ID, right? So means without ID missing, there should not be any employee. So primary key features are no duplication, no nulls. So that is something like you can set according to your requirement, a constraint to your table. So that we will be discussing in the constraint concept. Provides a very high security because as it is going to follow all the 12 Codd rules. There are some rules for the database. For a database to come into market as a product, some rules has to be followed by the company who has designed it. Some Codd rules. And this Oracle software, this database has followed all the Codd rules. Means a highest security is provided with this. That's a provide high security. Supports multi-users. Multiple developers can access a single table, same table, without any issue. Okay, so they can do all the operations: insert, update, delete. See, now if the two users are accessing the same table, when one person is updating, a lock is placed on the table, locking. Once the transaction is completed, lock is released and the data, modified data would be viewed by the other user as well. So this happens inside within few fraction of seconds. Okay, so that's the reason that we say it's a multi-user technology. It has a feature of error handling as well. The errors, if I'm doing some activity on a table, if any errors occurs, you can also handle the errors during execution as well. So this error handling mechanism we will be learning in the PL SQL concepts. Clear so far? The features, what is RDBMS, the installation wise, how to create a user and connect to the database with the help of a schema. Okay. Right. So here, next is we need to understand how this database connects to the user as a front end and how it gets saves the data in the back end. Now, as we discussed, the data would be coming from any input sources and the database we are going to install at the server side, right? So this is a client and server architecture with respect to a developer. You can understand this. Like the data would be coming from a front-end application. The front-end application can be anything. You may get an application on a Java application, .NET application, C, C++, D2K, any application. Okay, so on that application, you're just filling some registration form. When you're filling some registration form, it's sure like you may fill your registration ID, your name, address, contact number, okay, the purpose, whatever the details. And once you click on the submit button, those details would be transferred and stored in the backend. So backend in the sense at the server side, already you have installed your database, okay, Oracle database. On that database, you would be saving this information.
Lakshmi?
Yeah.
I have a question for you. Is this the first session?
Okay.
Is this the first session?
First session, yes, it's the first session.
I thought Murali was teaching the class.
Sorry, I'm not able to get you.
I thought Murali was teaching the class.
Oh, you mean you're just asking me, is this the first session, right?
Yeah, yes.
Yeah, this is the first session and just we have just understood the basic introduction about the Oracle. What is meant by Oracle? The installation part. And now we're just...
What happened to the instructor last week who was doing the demo, Murali?
I'm not sure. I'll just I'll understand from the Intelli team. They will be clarifying your query.
Oh, okay. Would you happen to have the curriculum?
Yeah, curriculum is already there.
Okay.
Yeah, I'll give it to you. Go and call mommy. She's doing laundry. She's downstairs in the basement, okay? Tell her she's in the basement.
Okay.
Okay? She's in the basement.
Ambrose. Is it Ambrose?
I'll give it to you. Wait.
Hello?
Yes, you can go ahead. Go ahead.
Yeah. Yeah, thanks. So here we are just discussing understanding the architecture of Oracle with respect to a developer, where the data would be coming from any front-end application, or you may get a data from an Amazon, Flipkart, anywhere, which would just get diverted to the database, right? So that on the database already you have installed your Oracle database. Now it gets set in the form of a object.
There's a lot of disturbance, Lakshmi.
Yeah, hope that's now fine, right, Siddharth?
Yeah, it's fine. Thanks.
Yeah, thanks. Well, so the data would be coming from any of the application, and that would be stored in the form of an object. So we mean to say in the form of a table. A table is nothing but a representation of rows and columns. You can design a table according to your input coming from the input sources. So how is that data getting moved to the database? With the help of some communication channels, you can design this JDBC and ODBC connectivities, Java database connectivity or open database connectivity. See, in a real time, the people who want to access the data from a database, they have to set these connectivities. If a Java developer wants to access a database, he has to design these connectivities in a form of a code. Once he executes that code, already the connection would be set and he can get the data, retrieve the data from a database. But as we are learning the SQL and PL SQL so we'll be concentrating more on the database, not on the front-end applications and the connectivities. So this much part we would just leave aside. Just for understanding, we considered it. We would be more focusing on how to design the objects, how to manage them, and all the stuff. Okay. Now, there you saw just a client and a server. What is a client? From the client, you may get some input to your database, which interacts with your database, right? And what is a server? Where you can install your database and stores the data for further reference. So that's a client and the server. Now this is how the data coming from a front end, whatever you have entered in the registration form would be on the server. You have installed a database. On the database, you have one table, which is in the form of rows and columns. In each cell, the data gets stored. Okay. So if you see this, you can see in the table itself, see it is in the form of rows and columns. This is one cell. It is in the first row and the third column. Vertically are known as columns and horizontally are the rows. It's in the form of a tabular form, right? The same thing here. Now, as we are going to start this program with the training with the SQL, that is a structured query language. You are going to follow certain syntax and write your query, your requirement, which would interact with your database and get the response. That is an SQL. In SQL, we are going to execute only one query at one point of time, not multiple queries, right? See, when I execute this query here, I have two queries here. Can I execute these two queries together? Not possible. SQL will take only one query and give you one result. Even though I have selected two and say run the statement, it is taking one statement to give me output. But if you want to run multiple lines together, that is a PL SQL concept, where I just club together and put it in the form of a group together and put it in the form of a block and then run it as a script. That is a PL SQL part. So in SQL, we are going to execute one statement at one point of time. Okay, so later we will be seeing in the PL SQL how to create a blocks and execute multiple commands there to fulfill the client requirement. Well, now to start, before starting in the SQL, we will be learning all these concepts, the 5 sub-components like DRL, Data Retrieval Language. As just already we saw select query. Here you're going to learn all the different ways of writing a select query with filtration, having clause, group clause, all the stuff, order by everything. That it is known as a data retrieval. Data definition, where you're going to create a new object, new table in your schema. How are you going to create, alter, drop, truncate, rename? Okay, all these commands comes under the data definition. And one more thing, data definition is an auto commit. Automatically, once you create a table, that gets already saved to your database. You can't unsave it. You need to explicitly drop it. It cannot be unsaved. Next component is DML, Data Manipulation Language, where you will be learning how to insert a data to your existing table, how to update, and how to delete. 3 commands are there in the data manipulation. The data manipulation is not auto commit. Whatever insertion you do, you can roll back, unsave it as well from the database before committing, before saving, I mean to say. Okay, we'll see all these examples on all these points. Data control, Means how are you going to control? We have executed this grant. While we created a new user, Intel, we use this keyword, right? In grant. Granting means giving some permissions to a user. So you can give a permission of accessing one table to other user, or also revoke. Revoke means taking off the privileges. Similarly, on the database, whatever the queries you execute, they are nothing but the transactions. So you can control those transactions. You can either commit them. Commit is something same like a save. Rollback is something unsave. And save point is something providing a time intervals between the transactions. So that at the end you can decide up till which point you want to roll back or commit. Okay. So, but before starting this creating a table and selecting queries, first we need to understand on what basis you're going to create the table structure. To a particular table, what should be the column name? What should be the table name? Okay, how a column should look like? What data it should take? These things we should understand before creating a table. Well, so for that we need to understand the data types. A column can take what kind of data, what type of data it can store. See, in this table, this column is taking only numbers. This column is taking only characters. This is in the date form. This again numbers, right? So already we have said this column should take only numbers. That's the reason it is taking numbers. I can't save here some characters. That is only because of the data types. Okay. Now see, this table name is what? EMP. And these are the columns of an EMP. Right? So this is based on an entity. This EMP table name is known as an entity. And this column names are known as an attributes, features. Or you can also call them as a data points. Okay. See, there is some relationship. When I said EMP, table name, employee, some things strike our mind. Some features of that word. When we are talking about employee, some things come. That employee should have an ID, that employee should be named, should have a name, some designation, the department number, salary, date of appointment, something, right? So those features becomes in turn the columns of the table. The entity about what we are talking becomes the table name, and what are the features of that entity becomes the columns. If suppose I'm talking about a student, what features strike us? Student should have a roll number, right? Student should have a name, right? Class, teacher name, in this way. So what happened? This becomes a table name and this becomes the columns. Okay, a table is decided. This should be the name and this should be the columns. Now we should decide this column should take what data. Roll number means only numbers. Name means only characters. Class means some you can pass characters or some Roman letters, numbers, symbols, right? Teacher's name should be again characters. Date of admission, again a date format, right? Date of admission. So that you're going to understand with the help of a data types. So in coming to the data type, there are two types of data types, simple and the composite. Composite data types we are going to learn in PL SQL. What is meant by composite means, according to the developer's need, he can design his own data type. Already there are some set of data types with Oracle. Apart from using those data types, a developer can create his own data type and use it in the program, in the coding. So such data type is known as a composite data type, which can't be used in SQL, which can be used only in PL SQL. Now, simple data type is something already a set of data types are designed by the Oracle. So using those data types is known as a simple data types. So we'll understand what are those simple data types. The first one, char. Char and some number, n. You can give some number here. Char is a data type which can store a single characters. I mean to say not a single, characters. A character minimum size can be 1 and maximum size can be 2000 bytes. It can store. If a column is assigned with a data type char, that column has a capacity to hold minimum 1 byte to 2000 bytes of characters. Now, how will you assign this data type to a column? The syntax is column name space, column name, the space, and the data type and the size. Column name, space, the data type and the size, and end with a semicolon. You can take any column name based on your table design. The data type is char, and the size you can take it from either from 1 to 2000 bytes. For example, here I have a char, ch1 is a column name. Char is the data type, 10 is the size. So what happens here in this case, a memory is allocated. ch1 is the column which is referring to this. ch1, a memory is allocated of 10 bytes. Out of this 10 bytes, what is the column data you're saving in this column? Just I'm saving a name as ABC. 3 characters I'm saying. Out of this 10 bytes, it may occupy some bytes. And whatever the remaining space here left out, it is wasted in the char data type. So unnecessary, I have reserved 10 bytes, but out of 10 bytes, I'm holding only few bytes, consuming few bytes. The left out bytes are wasted. It is not even reused by some other object. It is just wasted. Okay. So to overcome this disadvantage, what we do is we should use this char data types to such a columns where you're confirmed, where you're sure what kind of data you're storing to that. So what can be the column names? For example, status. If I want to capture the status of something, I can use, char of status is something, I'll give true, false, TF, 0, 1 or something. Then I can give char of 1. Gender. Gender can be either male or female, MF, 0, 1, something. Then in that scenario, I can give the char again of 1. Means only one character you can save it. Either the status T or F. Here either the gender M or F. So where you can't waste any memory space. So for such columns where the data is, you're sure what can be the data, for such columns you can take this char data type. Okay. But for the columns where you need to pass some characters which can vary from time to time. Okay. Which can vary. For that you have a data type known as a varchar2 of variable. Var means variable character of size ranging from 1 to 4000. So column name is ename, data type, and the size of 40. In this case, what happens? A normal already a 40 bytes size would be reserved as soon as you declare a variable. Now suppose I'm saying a name as ABC to this column. So out of 40 bytes, the required memory is consumed and the remaining space is reallocated for some other purpose. So it consumes whatever is required. So instead of 40, I can also put 400 also, 4000 also, not an issue. It will consume how much is required. So this is in the real time, we use this data type most of the time, where it will take any kind of input, variable input, and the data, it consumes whatever the required space and the remaining would be erased, given back. Okay. Apart from that, you have some more data types, date, which is explicitly for the date input. The date input is DD, MON, YY. This is the Oracle default form. There's no fixed, it has a fixed size. There's no increasing and decreasing along with hyphens. So that's the reason a column name, just a date. There's no size for it. So this is a declaration for a column of a date data type. Similarly, a number. I want to store a number. So number can be a whole number or a decimal point. For that reason, this number data type has 2 parameters, precision and the scaling. So precision means it will tell you how many max numbers I can store for this column, total number of digits. And scaling, something is optional, where you can exclude this. Once you exclude this, the number will store, that particular column will hold only real numbers, whole numbers. And if you include the scaling, the column will hold decimal points. So the scaling will understand after how many decimal digits you're putting a decimal point. Okay, so suppose for example, N1 is a column. I'm declaring a number data type of 5. That is a precision. Means overall, in this N1 column, I can store 5-digit number. Any number up till 5 digits. There is no decimal point. If I want to store decimal points, I should declare a data type in this way. 5,2 means what? Overall, in this N2 column, I can design 5 numbers. 3, 4, 5, 6, 7. These are the 5 numbers. Out of 5 numbers, leave 2 decimal and put a decimal point. This is scaling. So this is the input I can pass to this column. So this is how, with the help of precision and scaling, you can assign the data type for a certain columns. Clear? So using these data types, now we can design a table. So we are going to start with the first DDL commands, where you can create an object table, alter it, rename it, drop it, truncate it. All are auto commit commands. The first one, how are you going to create a table? This is the syntax. Create table, table name, and the list of columns for the table. Make sure that a table without columns can't be created. At least one column is must. So how will you design a column? As we just discussed with the data types, the column name, data type, and the size. So this is known as a column definition. So a table can have multiple columns. Table name here, any table name. See, whatever you can see here in the arrow sign, that the name can change. But create table is a keyword. You can't change this. It's a constant. This is a syntax. So first column definition, comma, second column, so on. So we'll just, using this syntax, we'll try to create a table in our schema. Okay. We'll try to create a student table following the syntax. Create table. The table name is student. What are the columns of this table? First column is roll number. Roll underscore number. Now roll number is the name of a column. Now data type. What value are we going to enter to a roll number? Purely numbers, right? So the data type which we know is number. Are we going to provide decimal points to this? No, right? Only whole numbers. What would be the max size of a roll number? 2 digits, right? So size I gave as a 2. So this is one definition for a first column roll number. Second column, put a comma. Second column is student name. S underscore name. Okay, I can't write the column name S space name. I can't write in this way. I have to just use an underscore name. So name of a student, multiple characters which can vary. So I can't take char data type. I should not go for that because unnecessary will be wasting the memory. So which is the data type? Varchar. And give any size whatever you want. No worries. Second. Gender. Now gender input I'll be giving as a male or female, right? Boy or girl or something. So single character is enough. Either I can give 0 or 1 also. So here you can use char of 1. Similarly, date of admission. Date of admission is something in a date format. So date is a data type. So mostly we have used all the input, I guess, right? All the data types. Close the bracket. Select it and execute it. So student table is created. I want to just see this table. Can I write a select query? Select all the columns from the table. What is the table name is? Student. Execute. So you can see the column names, but there's no data below it because we have not entered any input, right? I can also see the structure of a table. Structure means whatever columns, what is the data type you have assigned for this table. How to see a structure? Describe DESC and the table name. It's still executing. So this is the description about the student table. What the student table has, it has a column name, roll number, student name, gender, date of admission. What is the data type of each column? Number, size, varchar, size, character, date. So any object's description you can use by this describe and the object name. If you want to see the data under the table, you can write a select query. And this is the way how you create a table. Clear? So following this syntax. Okay. Now, once a table is created, now suddenly I just want to change something in the table, right? I want to change the column name. I want to change the data type. I want to increase or decrease the size. So what is that changing means? Alteration. Now I want to alter the existing table. That you can do with the command alter. What things we can alter? If you want, you can add a new column. If you want, you can change the column definition. Column definition means changing the data type or increasing or decreasing the size is a column definition. Renaming the column name, column name you can change, remove the column. So these 4 things you can perform with an alter. So we'll see the first one, how to add a column. Now already some columns are there in the table, right? I want to add a new column. The syntax for that is, you should say alter table, write the table existing table name. As you're adding, use the keyword add. What is that new column you're going to add? What is the new data type of it and the size? So this syntax is to add a single column. If you want to add multiple columns at once, after add, put a bracket and give the column definition. Let's see this student table, we have already added. How many columns we have? 4 columns, right? Now I just want to alter it. Alter table, the table name is student. I want to add. If I want to add a single column, I'll say column name. I'm saying C1 as my column name. Number data type and the size is 5. If I want to add a single column, I can just execute as it is now. If I want to add multiple columns, what I should do? Put a bracket. First column definition is done, comma, second column C2, varchar. And if I want to add a third column, I can put a comma and then add. Execute it. Student table is altered. Now if I want to see the description, describe table name. Now you'll get the new structure of this student table. See, old columns plus 2 more columns and its data type. So this is to add a alter, using to add a new column to our tables, right? Similarly, I want to modify. I want to change the data type. I want to increase or decrease the size of a column. For that, I'm not adding a new column, I'm modifying it. So what you should do? You should only use a keyword modify. Now, how will I modify? Now, the simple way of doing this, see, this command is to add a new column, right? New column. Now, keep as it is, just instead of add, make it modify. Just it's an easy way to remember, modify. Now, modify means what? What columns you can modify? Already columns which are present. Now, which column I want? Roll number. I'll write here. Roll underscore number I want to modify. What you want to modify? Already it is a number. You want to make it as a increase the size? Yes. So I'll say increase to 5. It was 2. I want to make it to 5. I want to modify C2. It is already varchar. Do you want to make into data type? So 2 columns I'm modifying. Execute it. So student is modified. Check in the description again. Now see, the first column is increased and the last column it modified the date. Okay, so in this way you can even modify the data type, right? Similarly, I want to change the column name. Already there are some column names. I want to change it. For that, syntax is alter table name, rename column, old name to new name. Now here I can change the name only one column at one point of time. Multiple columns we can't change. So alter table student rename column. What is the old column? Instead of roll number, roll underscore number, I want to make it as just only row. Execute. Table is altered. Check in the description. Now that name is column name is changed. Right? Similarly, I want to remove the column, dropping of the column entirely from the table. You can do so. You can drop single column, also multiple columns. If a column is dropped, if you have some data under the column, the data also gets dropped. Everything gets deleted. Now to drop a single column, alter table name, drop column name. If we want to drop multiple columns, what you should do? Just put this everything in a brackets and the column list separated by commas. Now here, alter table student drop column C2. Only one column also I can drop. See, drop column name. Table is altered. Description. One column is dropped. I want to drop multiple columns. So what you should do? Just after drop, C1 I want to drop, and date of admission also we want to drop. 2 columns. Put it separated by a commas. Okay, so right now in the table we have only 3 columns. So these are the some alterations you can do with the existing table. Clear? Now similarly also I can drop the table and truncate the table as well. This also comes under the DTL commands. Now to just drop a table, it would be better. This student table is a blank table. Now to see the correct way, we should have a table with a with the data. In our schema, we have a DEPT table, right? So select data from DEPT. This DEPT table has some 3 columns: department number, DNAME and location, and 4 rows. This is the data. I'm just making a cloning of this table. I'm going to create 2 new tables based on this existing table. How to do that is create table. This is a syntax, right? Create table, I'm saying T1. But how you want to create a table? I'll not give any syntax. Here on the top, I gave create table and gave the column definitions. But here I'm not going to give a column definition. I'm going to say create a new table T1, same like this DEPT table. So how will I know what is the DEPT table? Select query. If I take this select query, I understand what is there in the DEPT table, right? If I execute this, this is what the data I got. I should take the same data and put it in T1. How will you put it? Create a new table, same like this DEPT table. For that, I'll just use as. Create a new table as DEPT table. Just say collectively take it everything and just run. T1 table is created. Similarly, I want to create one more table, T2. Same query. T2 is also created. Now, select start from tab. How many tables we have? We have now in our schema some 5 tables. EMP, DEPT were there from before with the script we copied. student we created, and T1 and T2 just now we created. Select data from T1. T1 is containing, see, this is the data. Similarly, select data from T2. T2 is also table. Same information, you will find it there. Now, using these two tables, we are going to use drop and truncate. We'll see the difference. First, I am saying I want to drop this T1 table. Drop table name T1. Both are auto commit commands. Table is dropped. Once table is dropped, do you find the table in the list? Select start from tab. See, there is no table T1 here. Can I write a select query on this table? As there is no table, nothing you will find there. It says there is no object named T1. See, table of view don't exist. As table itself is not there, do I find any description? Nothing, right? You will not find any. No description. See, table object doesn't exist, so no description. Means what is the conclusion of drop? Whenever you drop any table with data, the table completely drop from table tab. There is no selection, there is no description. Entirely data, column list, everything gets dropped. Clear? Now the same thing I'm going to truncate the second table T2. Truncate table T2. Once table is truncated, do I find the same thing? We'll check with the second table as well. Select star from this is T2. And this is T2. From tab, do truncate. In truncate, you see the table, but this was not with the drop. Do you find any select data from T2? There's no data, but you can see the columns. You can see the columns means there is a description. That is the difference. In drop, if nothing is there, in truncate, data is removed, but structure you can see. But actually what happens is internally, whenever you truncate, two operations takes place. In first step, it acts like a drop only. The data and the structure, both gets dropped. And in the second step, it will recreate the structure. As a new structure is recreated, you feel as if the column list is available, but no data. Okay? So that is the difference between the drop and the truncate. Okay? Is that clear to everyone? Any queries? So we have just discussed overall all the DDL queries: creation, alteration, modification, renaming, dropping, truncating, and how to create a table. So any queries here? If you have any queries, just please. Fine. We can do one